Hey, welcome to day 4 on our congruence chapter. Today we're going to take what we learned last time about congruent triangles and now apply it to proofs. So the 5 ways we learned last time were called side, 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 angle, side, angle, side, angle, 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 side, and the last weird one, doesn't match anything, is hypotenuse, leg. So those are our 5 choices in proving things. We're going to look at the ways you can say sides are congruent. It could be stated in the given. Definition of midpoint. We know midpoint makes 2 segments congruent. A segment bisector can make 2 segments congruent. Reflexive property. We learned this in chapter 1 in properties, but we didn't use it very often. Reflexive property is used when something is congruent to itself. And we use that when a side is congruent to itself, like more specifically, like when it has a shared side. We had those in the pictures, and I said that's something you can assume if they share a side that's congruent. So we write that in the proof as reflexive property because it's the same as it's equal to itself. Angles, different ways angles might be congruent, might be given in the statement. We talked about last class, vertical angles are congruent. These are, if we have parallel lines stated, then we can use any of these parallel lines congruent statements. And another one we have angles congruent is if something was bisected, but angles bisected, we know that they are congruent. So we're going to start off with this one. This one has a lot of different things that are given. And so in this proof, this is just like an example of the way some people do it. They like to see everything listed out. So they actually wrote the givens on 3 separate lines here. So you would just write given on each of those. Again, some people just like to see things stated out. So PQ in this picture, it's congruent to ST. QR is congruent to RT. And then they tell us R is the midpoint of PS. Well, we know if R is the midpoint, then we know these 2 segments are equal. So that's what they said. If R is the midpoint, then we know PR is congruent to RS. And remember, if it gives you a key word, we're going to say definition of midpoint. That is what a midpoint does. It makes 2 equal segments. So now if you look at what we have marked, now we can say the 2 triangles are congruent by side, side, side. When you are doing this, you always want to make sure that there are 3 things listed out in order to prove things are congruent. Because all of our things require three items, 3 sides, side, side, side. Side, angle, side, those are 3 things. Angle, angle, side, that's 3 things. So in this, I'm going to highlight, I have a segment, another segment, and another segment. So I said 3 segments are congruent. So my reason here is side, side, side. Okay, let's look at the next one. You'll notice there's no algebra in these problems. We're just trying to prove triangles are congruent based on those letters that we used last time. We'll start off with the given. You can write the given on 1 line. You can write the given on 2 lines. The way the boxes are, I just wrote them on separate lines. Again, it's okay to write them on the same line. A lot of times we will not give you boxes. We will just ask you to write the proof. So then if it's easier to write it all at once and just write given, that's fine. It makes the proofs look shorter. So in this picture, I can mark that it was given that JM is congruent to NL. And angle JMN, this angle here, is congruent to LNM, this angle up here. So I only have 2 things marked. So then you go back to what we learned last class. Is there anything that we can assume would be congruent in this picture that's not marked? And in that case, this segment here, they share this segment. So I'm going to say for step 3, the segment MN is congruent to segment MN. These 2 segments are congruent because it's a shared side. So our reasoning is called reflexive property. So now I can say the last step, I have 3 congruent signs in my problem. I can now say that these triangles are congruent. It takes 3 congruent symbols to show that triangles are congruent. I take that back. It takes 3 congruent symbols most of the time, except for hypotenuse leg, but that has to have the 90-degree corner. So these triangles are congruent. If we look at the picture now, we would have side, an angle, and a side. So I will put step 4 is side, angle, side. Alright, let's look at the next one. Remember, you can always pause the video if I write too fast to get caught up. Example 3, we're going to write down our givens. Again, you can put it on one line, you can put it on separate lines. Oops, that's supposed to be an angle. So both of these were just in the given. I was just copying down the given from the beginning. That's how we always start our proofs. So in the picture they said WV is congruent to YZ. They said VWX, this corner here, is equal to ZYX, this corner up here. Okay, so we only have 2 congruent signs and it takes 3 to prove triangles are congruent. So what else in this picture could you mark if something's not given? We don't have a shared side, so I can't mark a side. We have no parallel lines, so I can't mark any like alternate interior or anything like that. But I can mark, this would be considered vertical angles. So we're going to mark these 2 angles are congruent. Now when you do that, you want to try and make sure when you write it down you match up the angles. So let's say I start with VXW is congruent to, you need to pay attention to your picture. Okay, V in this particular picture would match up with Z because they don't have the marks on them. And then X and then Y. Okay. So now you have 3 congruent symbols. So you want to look at your picture now and decide, how can I say these 2 triangles are congruent? So it looks like we have a side, an angle, and an angle. So 2 angles and another side, we call that angle, angle, side. Alright, next one's very similar. The next one is 2 overlapping triangles, so if it helps to pull these triangles apart to see this better, that might help. So I'll draw that to the side. If you want to pull this apart to show the 2 triangles, it says we have triangle WZY would be one of them. See, WZY. And if I draw the other one triangle this direction, because it's just overlapping the other triangle, this would be triangle XYZ. Okay, so if you push these 2 together, you form this picture. So if it's easier to pull those 2 triangles apart and look at it like this, that's fine as well. So this one, we didn't give you boxes, so you can write it down however you want to write it down. I'm going to put those 2 perpendicular statements together, and then I'm going to put this congruent statement by itself. You don't have to do that. You can write it all together. The reason I kind of separate is because I like to see my three congruent symbols, but this one has a perpendicular symbol instead of congruent. So if you remember, perpendicular makes angles form 90-degree angles, or right angles. So in this picture, WZ is perpendicular to ZY, so that's going to be a right angle. And XY is perpendicular to ZY. That's going to be a right angle. So because those are right angles, I'm going to say angle WZY and angle XYZ are right angles. If you don't want to call them right angles and you just want to state that they are 90 degrees, I would be okay with that. So either option, something to show you understood what perpendicular meant. So I'm going to say definition of perpendicular lines. And you can even use the symbol if you don't want to write out the word perpendicular. So then our second given we had was did I copy that down? Yes, I copied it down wrong. This says WY. That's supposed to be a Y. WY is congruent to XZ. So WY is congruent to XZ. Okay, so I have two things. It takes three things in order to prove something's congruent. If you look back at this picture, before I tore it apart, do you notice they both have that line in them? So if they both share the line ZY in both pictures, we know that that is congruent. And anything that's congruent to itself, a shared side, is called reflexive property. Okay, I think I have enough information now to say the two triangles are congruent. And if you look at these individual pictures over here, we have a right angle, we have hypotenuse, and we have a leg. So this is HL, hypotenuse, leg. So in this one, the three things, I didn't have three congruent sides, but I had two congruent sides and a 90-degree angle, which means that I have enough for, in this case, the hypotenuse leg. If instead of giving me the hypotenuse, if it had given me this side instead, we could have had side, angle, side, even though it was a right angle. So it's okay, just because you have a right angle doesn't always assume that it's hypotenuse leg. It could just be another angle that was in the picture. Alright, the last type of proofs we're going to deal with is CP-CTC. Basically, it adds one less step into your proofs. From the beginning, or from, last class, we learned this means corresponding parts of congruent triangles are congruent. It's a very long thing. That's why we just, instead of writing that out on every proof, we just write the initial CP-CTC. Corresponding parts refers to angles or sides that we can prove congruent. So when you ask to prove parts are congruent, but first you must prove the triangles are congruent. So this is why I said basically you're adding one or two more steps to our last proof. So you still have your givens. You want to prove the two triangles are congruent, and then you can say prove that the parts are congruent. On all the other examples we had, the last line always said prove the triangles are congruent, right? Prove these triangles are congruent. And we proved that by any of those 5 words that we had, or 5 sayings we have: side, 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 side angle, side. Those 5 things are what we always ended our proof with. Well, now instead of saying just prove the triangles are congruent, they want us to go a step further and say that different parts are congruent. Because we learned if triangles are congruent, then you know all of their individual parts would match up to be congruent, their corresponding parts. So we'll start off with our given. PS is parallel to QR, and angle QPS is congruent to angle SRQ. I'm going to mark those things in the picture. PS is parallel to QR, and angle QPS, this angle up here, is congruent to SRQ. Alright, so it didn't really give us a lot to prove the triangles are congruent. So what else can we assume even though it's not marked? One of the things, when you're looking at these two triangles in the picture, we can assume that the side that they share is going to be congruent. Okay, we know that's congruent to itself. So I'm going to say QS is congruent to QS. Anything that's congruent to itself or a shared side is called reflexive property. So I still only have one angle and one side. And so it's not a 90-degree angle, it can't be hypotenuse leg. So then you notice there's a reason they give you parallel lines. The reason they told you it's parallel lines, if you look back at the first page, here are the ones that you can use when you have parallel lines. You're going to look in the picture. Can you find alternate interior angles that are equal? Alternate exterior or corresponding angles. So in this picture we have parallel lines, so I'm going to use alternate interior angles and say this angle here is congruent to that angle. Because normally our picture with parallel lines, we don't have these two sides, we just had parallel lines and the transversal that went through it. So we could say that these two angles here are on alternate sides of that line. So I'm going to say, if I wrote that out, angle PSQ is congruent to angle, so PS would match up with RQ. And my reason is alternate interior angles. So now if you look at this, we have 1, 2, 3 congruent signs, so I can say the triangles are congruent. And you can write these triangles in any order. I'm just copying down the way I wrote those, just because it was right there. So in our picture we have angle, angle, side, or side, angle, angle, however you want to write that. We have two angles and then a side. So now that I know that the triangles are congruent, I can now say any part in that triangle, any angle, any side, is congruent. So I could have said, they gave us angle P and Q. I could say side PS and side RQ. Or this one asks for side PQ and RS. It doesn't matter. Once the triangles are congruent, you can say any part of the triangle is congruent by CP, CTC. Alright, what I would ask for you to do on this next one is I would have you try it on your own. Pause the video, see if you could do this one on your own. Okay, hopefully you had a chance to work that out. I went ahead and wrote down the givens. I'm going to kind of go step by step. If you want to start off with the parallel lines, we have BC is parallel to EF. And anytime you have parallel lines and they have a line that connects it, we could use what we call alternate interior angles, we have two options here. You could use this angle is congruent to that angle by alternate interior. You could use this angle is congruent to this angle by alternate interior. You don't have to use both of those. You can use both of those. I'm just going to show you different options on how to do this one. If you want to do both sets of them, you could actually write them both on the same line. So you could even call it angle E is congruent to angle C. And angle B is congruent to angle F. And both of those would just be called alternate interior angles. You can only use that if you know the lines are parallel. Some people might not have saw that one. Some people might have saw, like at angle D here, we have vertical lines. If you want to use our vertical angles, though, you have to use these three letters like B, D, C, and F, D, C. You can't say angle D is congruent to angle D because there's actually two angles there. Okay, it's not the same angle. It's not a shared angle. It's two separate angles. So you would need to identify both angles. So vertical angles is another option we could have used. The other thing I noticed is in the given, they give us the word midpoint. So it says D is the midpoint of BF. So that would mean this segment here is congruent to that segment there. And I'll call that definition of midpoint. So I now have technically three congruent signs in my proof, so I can say the triangles are congruent. So on all these proofs, we're trying to prove the triangles are congruent so that either one, that's the last step they want us to do, or if the triangles are congruent, then we can prove a part is congruent. So let's see. The way I have it marked is I have angle, angle, and then a side. So I'm going to use angle, angle, side. If you chose to use the vertical angles and this angle, you might have angle, side, angle as your choice. If you did this angle and this angle, it would still be angle, angle, side. So you either on this one, your two options are either going to be angle, side, angle, depending if you use the vertical angle and this side, or it would be angle, angle, side if you use the other angles. Okay? So now I've proven the triangles are congruent. I had my three congruent signs. So the last step now is to say segment ED is congruent to segment DC. And it's because these are called parts of the triangle, so we say CP, CTC. The corresponding parts are now congruent if the triangles are congruent.